Hello everyone. Today I am going to give a lecture on synchronous generator. It is also known as alternator. So what is alternator or synchronous generator? So an alternator, it is an alternating current voltage generator. So already we have discussed DC generator where which generates DC voltage or direct current voltage. But to generate the alternating voltage, synchronous generator or alternator are used. It is also called as a synchronous generator because here in this case, in the DC generator, the field system is stationary and armature rotates, right? We have studied in the DC generator, armature rotates with a stationary magnetic field. But in the case of alternator, the field system is rotating and the armature or conductor part is stationary. So, because of what is the reason? So, if the alternator having a stationary armature has several advantages. So, what are the advantage? So, the generated voltage can be directly connected to the load so that load current need not pass through the brush contacts, one of the reason. Second one, it is easy to insulate the stationary armature for high AC generated voltages which may be high as 11 kV to 33 kV because in this case synchronous generator generates electrical power about 11 kV. So then it will be stepped up to higher voltage of 132 kV or 220 kV and 400 kV for transmission lines. But at the distribution point, it is again stepped down to 400 volt or 220 volt for use in industry, offices and homes. So, here because of the armature part is stationary, it is easy to insulate the armature, stationary armature, and the sliding contacts, that is slip rings, are transferred to the low voltage, low power DC field circuit which can be easily insulated. And the armature windings can be easily braced to prevent any deformation produced by large mechanical stresses set up due to short circuit currents, large centrifugal forces that might be set up. So, here in the generator what we have studied, armature part conductors are rotating with the stationary magnetic field. But in the synchronous generator, it has what is the rotor part. Rotor part means it is a magnet. Magnet part is rotating with the armature conductor stationary. But here we need to remember synchronous generator is a alternator or it is a alternating voltage generator. So how to generate the alternating voltage? Because what we have studied here, it's a synchronous generator generates three-phase AC voltage. So already we have studied in the three-phase AC circuits, to generate the three-phase AC signal, there should have three set of windings. Okay, it should have three set of windings R, Y, B, and it should be connected in such a way that the E.M.F induced in the three windings are 120-degree phase difference with each other. Okay, so there are three set of windings which is a stationary windings and rotor part has rotating magnets. Okay, and here it has field winding. Rotor also has field winding, what we have studied in the DC generator, so that it will make the particular magnetic material into electromagnet to generate the magnetic field. So what will happen here, it should have some excitation voltage for the field winding which is wound on the magnets. So that excitation voltage is in the form of DC. So DC supply will be given to the field winding. It is wound on the magnets so that it will generate the required desired magnetic field, and that rotor magnets are rotating part. But whatever the conductors which are present in the armature structure, which is a stationary part, which is known as a stator. And the armature has three set of windings, RYB. So according to electromagnetic induction, whenever the rotor is rotating, so something prime movers are required. Prime mover based on the speed. It may be a steam turbines or petrol engines or diesel engines or something electric pumps, electric motors required to provide the mechanical energy to the shaft. Because synchronous generator is a three-phase AC generator. What do you mean by generator? Generator which converts mechanical energy into electrical energy. So mechanical energy should be supplied at the input side, so that which converts the mechanical energy into electrical energy. So where we need to supply the mechanical energy? Mechanical energy is supplied to the shaft by, because it should be rotate. Shaft should rotate, along with the shaft magnet should rotate. So that rotation mechanical energy is supplied by some prime mover. It may be a steam turbines or water turbines or something petrol engines or something diesel motor or electric motor, which supplies the mechanical energy. When the rotor rotates, what will happen? Which will, so that because of the rotation of the magnetic pole, no? Here armature conductor will cut the magnetic field lines, because magnetic field lines generated by the magnets, so that, so because of the rotation, uh, the conductor will experience alternatively north and south pole. Because of the north and south pole of the magnets are rotating continuously, the conductor, it experience continuously north pole experience, south pole experience. So that what will happen? There is a changes in the flux line cut by the conductor. So according to the Faraday's law, whenever the flux linked by the conductor changes, E.M.F induced in the conductor. So continuously magnetic flux lines cut by the conductor, which will result in the E.M.F generated across the conductor. But here there are three set of windings. So those set of windings are placed with a 120-degree phase difference with each other, so that EMF generated across the conductors, different set of windings also 120-degree phase difference with each other. So it generates three-phase AC signal. So this is the setup of the synchronous generator. Here it is a very large, very big machine which generates the three-phase AC signal, and also many application requires the frequency of AC supply to be constant. So constant frequency of generated power can be obtained only if the generator runs at a constant speed, called its synchronous speed. Hence the name synchronous generator. So large size generator are also called as alternators. So the constant frequency should be generated at the output side, and because of the constant speed generator, which is called as a synchronous speed, hence it is a synchronous generator. So it is very large machine which generates around 11 kV, 11 kilovolt three-phase AC signal, and it should have the prime movers like the something external machine required to provide the mechanical force to the shaft, so that which generates the electrical energy AC signal. And here the construction difference between the what are the different constructional features or construction of the uh, alternator. So what are the parts of the alternator? So there are two main type. One is stator, another one is rotor. Already I have mentioned stator is a stationary part. Here armature conductor is armature structure with the conductors are placed as a stationary part, and rotor, which is the rotating part, magnet part. north south pole. You can see in this diagram the central part along the shaft, that is rotating part. Okay, so rotor is a magnet, stator is the armature with the many slots where conductors are placed. What type of conductor? Three phase windings are placed. Three set of windings. One is R, red, yellow, blue. So three phase windings are placed on the armature slots, so that which generates the EMF in the winding, and what type of supply voltage we are getting at the output side. Output is three phase supply. So alternator or synchronous generator is called as a three phase AC generator. So you can see in this diagram also. So windings, field winding or pole winding are wound on the north-south magnet, and that will be excited. So current should flow through the field winding to excite the magnet. So that supply voltage is in the form of DC. It's also called it as excitation voltage. So excitation current IF flows through the field winding, so that because of the current it generates the magnetic field, and how much what is the desired magnetic field, that can be generated based on the amount of the current flows through the field winding. And stationary part is a armature structure, and three set of winding A, B, C, and you can see three stator windings 120-degree apart. Already we have studied in three-phase AC circuits, and which generates the EMF. You can see in this right side diagram, red, yellow, blue. A means red, yellow and blue waveform with a 120-degree phase difference with each other. So this is the stator coil outputs. So it is a three-phase AC generator and synchronous generator, or it is also called as a alternator. And rotor of the alternator are classified into two types: silent pole type rotor and non-silent pole type rotor. So what are the difference between the silent pole type rotor and non-silent pole type rotor? So only rotor part or rotor part of the alternators are classified into two types of silent pole type and non-silent pole, or projected pole type. This is also called it as a projected pole type, and one more non-silent also call it as a cylindrical pole type. So what do you mean by projected pole type or silent pole type rotor? Here poles are projected out from the surface. You can see in this diagram the rotor part. Only the rotors are classified as a silent pole and non-silent pole. In silent pole or projected pole type rotor, poles, N north-south poles, are projected out from the surface. Okay, second one, field winding on the projected parts. Pole coils or field windings on the projected part. You can see the thick black color, thick black line represent it is a field winding on the projected parts. And here non-uniform air gap. So air gap is not uniform in this case, and large number of poles are required. In this silent pole type, there are large number of poles. 30 to 36 poles are present in the silent pole type rotor. And water turbines are used as a prime movers in this case. Water turbines are used as a prime movers. So water turbines are used as prime movers. Prime mover means which supplies the mechanical energy to the generator part, or which gives the mechanical energy to the shaft, so that along with the shaft rotor rotates. So water turbines are used as a prime mover and works efficiently at low speeds. These are the features of silent pole type rotor. So you can see in this diagram, silent pole, the projected poles are, or poles are projected out from the surface. field windings are placed on the projected parts, and there is a non-uniform air gap, but there are large number of poles present. Water turbines are used as a prime movers to give the mechanical energy works efficiently at low speeds. This this is about silent pole type rotor. So here construction of the silent pole type already we have shown. The projector poles made up of from the lamination of steel. Rotor winding is provided on these poles and it's supported by pole shoe. Silent pole rotor have large diameter and shorter axial length. This is one of the future. It has a large diameter because many large number of poles are present, 30 to 36 poles. So it has a large diameter and short axial length. Axial length is short and generally used in lower speed electrical machines. They are used in lower speed electrical machines, say 100 rpm to 1500 rpm. So silent pole type rotor has larger diameter and shorter axial length and used for the low speed electrical machines. And also the flux distribution relatively poor than non-salient pole rotor, hence the generated E.M.F waveform is not as good as cylindrical rotor. Silent pole synchronous generator are mostly used in hydropower plants, which is used in hydro power plants. And what is non-silent type? It's also called as a projected, cylindrical rotor type. Non-silent pole rotor or cylindrical rotor. You can see here there is no any projected parts in the rotor. So there is no parts are projected out from the surface. So it is in the shape of cylinder. That's why it is called it as a cylindrical rotor. Okay, it is a non-silent or cylindrical rotor, and in the slots made on the armature, many conductors are placed which are 120 each other, so that it will generate the E.M.F in the armature. So non-silent pole rotors are cylindrical in shape, having parallel slots in it to place rotor windings. It is made up of solid steel. The construction of non-silent pole rotor is shown in figure above. Sometimes they are also called as drum rotor. They are smaller in diameter but having larger axial length. Cylindrical rotor are used in high-speed electrical machines, usually 1500 rpm to 3000 rpm. Windage loss as well as noise is less as compared to silent pole rotors. Their construction is robust as compared to silent pole rotor. Number of poles is usually 2 or 4. Damper winding are not needed in non-silent pole rotor. Flux distribution is sinusoidal and hence gives better E.M.F waveform. Non-silent pole rotor are used in nuclear gas thermal power plants. So these are the here the number of poles are usually 2 or 4 and it is used for the high speed application. Okay, so and also used in nuclear gas thermal power plants and which is used in high speed electrical machines usually 1500 rpm to 3000 rpm, so that the this whatever the non-silent pole type rotor has better performance than the silent pole type rotor. What about the frequency of the generated E.M.F? It should generate the constant frequency. There is no changes in the frequency. So what is the equation for calculating the frequency? So frequency, one cycle is generated in a armature coil when a pair of field poles passes over the coil. The number of cycles generated by one revolution of the rotor is equal to P by 2. So you can derive the equation. Frequency is number of cycles per second, but what is the how we can write in terms of uh, power or number of poles into n divided by 120. So frequency, number of cycle per second. So number of cycles are classified into number of cycle per revolution into revolution per second. So here number of cycles per revolution, already it is p by 2 into revolutions per second, it's rpm by 60, n by 60. Okay, so number of cycles per revolution p by 2 and revolution per second it's n by 60 and total it is pn by 120. This is the frequency of the generated EMF. What is synchronous speed? So machine which runs at synchronous speed is called synchronous machine. Synchronous speed is the speed of the revolution of the magnetic field in the stator winding of the motor. It is the speed at which the electromotive force is produced by the alternating machine. Thus, an AC machine in which rotor moved at a speed and built a constant relationship between the frequency of the voltage in the armature winding and the number of poles is called synchronous machine. Ns is equal to 120 F by P. This is about the synchronous speed. Okay, I will continue the next topic in the next class about the pole pitch and EMF equation, and just go through the video and try to understand this one. Thank you.